often use batteries when we need to generate an electric current for our toys, etc. But the electricity that we use in our homes is generated without using batteries. We have big power plants for that purpose. Have you ever wondered, how is it possible to generate electricity on such a large scale? What phenomena do they make use of? So, is it possible for us to create electric current without using any batteries? Let's find out. We already know that if we pass an electric current through a coil, it generates a magnetic field, which means an electric current can give rise to the magnetic field. But a scientist named Faraday performed a series of experiments and found that the reverse of this is also possible. He found that the changing magnetic field can generate an electric current. So, yes, we can generate an electric current without using any batteries, just by using changing magnetic fields. Let's experiment to see how a magnetic field can generate an electric current. For that, we need an electric circuit, basically just a coil and something to detect the presence of current in the circuit. Faraday used a galvanometer for that purpose, but we can use a bulb instead. A bulb will glow if current flows through the circuit. And the most important thing is, we don't need any batteries as we are trying to generate an electric current only by using changing magnetic fields. So for magnetic fields, we will require a magnet. So let's start the experiment. Place a magnet close to this coil and see what happens. Absolutely nothing happened here. There is no glow in the bulb. That means there is no current flowing in the circuit, even though there is a magnetic field. Now let's just move the bar magnet near the coil. Look at that. We got a flash of light and then it disappears. Now pull the magnet back. Did you see a flash? This means we have created electricity without batteries for a split second. But it seems to work only when the magnet is moving. Now, what if we keep the magnet at rest and move the coil instead? Of course, we can create electricity. So look here again. We saw a flash of light when the coil was moving. So this means that one of the two, the coil or the magnet, has to move to generate electricity. Let's explore this idea even further. We saw that when we move the magnet closer or moved it away, that's when the bulb glowed. When we move the magnet closer to the coil, the magnetic field strength increases. When we move the magnet farther away, the magnetic field going through this coil decreases. And during this time, we could see a flash in the bulb. Thus, it can be concluded that changing the magnetic field passing through a loop produces an electric current. So, the current that is produced over here due to a changing magnetic field is called an induced current. The voltage here is known as induced voltage, and this phenomena is called electromagnetic induction. So, electromagnetic induction is a phenomena in which when you change the magnetic field through a coil, it induces a voltage or a current. This is something that has powered up our entire world. It's been more than 200 years since this phenomena has been discovered by Faraday. But even today, all the electricity that we get at our home is produced by electromagnetic induction. Isn't it amazing?